Alright, let's do a short little intro into periodic functions. We'll start off with what is a periodic function. It's a function that repeats itself and its values at regular intervals. A good example of this is a trigonometric function, the sine function, the cosine function, the tangent functions. There's secant functions and whatnot as well, but they're not used as often. The most common ones that are used are the sine and cosine ones, but periodic functions are important because they're so often found in nature and many of the things we do in daily life. Now, what does this look like mathematically? It's generally shown like this: f of x plus p equals f of x, where x is any point on the x-axis and p is the period itself, so the interval at which it repeats in. This is just a very basic form of it, the way it's often shown without any specifics given. There's only really two ways to do this that you'll work with, and this is a piecewise function or a trigonometric function. The piecewise function has to be defined normally in sections. If it repeats, it normally only repeats over a certain interval unless it's given as it repeats, like every even or every odd. Now, what does this look like graphically? The first example we have is the sine function, where you see sine of 0 equals 0 and the period equals 2 pi. And we know the period equals 2 pi because the function begins to repeat itself right at the 2 pi. It's 0 here, it comes down, it comes back up at 2 pi. You can see it repeats even before and after this. This is a pretty standard periodic function that you'll work with, one of the most basic. The second one right here is more of an irregular one. This would normally probably be multiple trigonometric functions used in the same function. You see it can go up and down, but it goes up and down. It has these nice curves at the maxima and the minima. This defines how you can look at different periods. This is one cycle from x1 to x2. It's also one cycle from x3 to x4. The distance from x1 to x2 is equivalent to the distance from x3 to x4. The third example is a triangle wave, and this would generally be given by a piecewise function because there's really no other way to make this graph. What are examples of this in the real world? The motion of a rocking chair as it moves forward and backward. It repeats itself constantly as long as you put in the same force to it. Frictionless pendulum. It will swing to the same distance back and forth constantly. The same maxima on each side with an equilibrium point in the middle. A phone ringing. This is one of the examples that wouldn't be represented by a trig function, since it would either be ringing or not ringing. It would look more like a square wave. That would look something like this. It would look like that's a bad drawing. Like this. Where the x-axis would be at the bottom here. So this would be the ringing portion, and this would be the not ringing portion. And a game of Pong, if you assume just measuring its x-coordinate left and right, assuming that you're not playing the versions where it speeds up as the game goes on. Now, I'll go into a couple examples in a later video on this, but this should give you an idea of what a periodic function is, which is simply just a repeating function that repeats over a regular interval. Alright, I'll see you in the next video.